Good morning, dear student. In today's lecture, we discuss the important point, that is the factors affecting on pi back bonding. So we already discussed what is the back bonding in case of carbonyl ligand, and we know that as the back bonding is increases, the metal carbon strength is increases. As metal carbon strength is increases, bond order increases, stability increases, force constant increases, and the frequency is also increases. But if you consider the carbon oxygen bond, due to the back bonding, the carbon oxygen bond get weak, its strength is decreases. Due to this, bond order, stability, force constant, and frequency is also decreases. So what are the factors which affects the pi back bonding? The first one is the charge. The first one is charge on metal. Charge on metal. So this is the first factor, charge on metal. So for example, if you consider these are the metal ion, it is present in m plus 2, m plus 1, then m, okay, it is in neutral, m minus 1 and m minus 2 oxidation state. So for example, the metal ion it is in plus 2 plus 1 neutral, minus 1 and minus 2 oxidation state. Okay, so we know that as the negative charge on the metal ion or metal atom is increases, the electron density is also increases. That is, more the negative charge, more the negative charge, more the negative charge on metal atom, on metal atom, more the negative charge on metal atom, electron density, electron density, electron density is also more. More the negative charge on metal atom, more will be the electron density. Electron density is more, and as the electron density is increases, the back bonding is increases. So in other words, in simple way, we can write as negative charge, negative charge on metal increases, electron density increases, and due to this back bonding, due to this back bonding, pi back bonding is increases. Due to this pi back bonding is increases, and due to the increasing pi back bonding, metal carbon strength is increases, but the carbon oxygen strength is decreases. So this is the first factor, that is charge on the metal. We consider the metal, not a complex. So in this case, if you consider the example, previous example, that is m plus 2, m plus 1, m, m minus 1 and m minus 2. So which metal ion or metal atom having more electron density and more back bonding? Because if you arrange this by decreasing order, if you arrange this metal atom by decreasing order of back bonding, then we know that there is a more negative charge on metal atom, and there is a more electron density and more back bonding is there. So this is the case, that is m2 minus is first, then m minus 1 is there, then neutral is there, then m plus 1 is there, and then m plus 2 is there. So this having m minus 2 having more pi back bonding, and m plus 2 having uh, uh, we can say there is a weak pi bonding because it is present in plus 2 oxidation state. It is electron deficient. Therefore uh, it does not we can say that it will shows little back bonding, okay, or it does not show any pi back bonding because it is present in plus 2 oxidation state. It is already electron deficient. So this is all about the first point, that is charge on metal. So as the negative charge on metal is increases, the electron density is increases and the back bonding is increases. So we are very much familiar with this point, that is as the electron density is increases, back bonding is increases, and due to this metal carbon strength is increases but the carbon oxygen strength is decreases. Second factor, it is considered as it is considered for the complexes, the charge on complexes. Again it is the charge on the metal is there. We in the first point we consider only the metal ion, but in the second point we consider the whole organometallic complex, that is metal of low oxidation state, metal of low oxidation state, metal of low oxidation state in complex, metal of low oxidation state in complex favors pi back bonding, favors pi back bonding, favors pi back bonding. So in this case, in this second point we consider the complexes. For example, uh, we discuss some complexes and the carbonyl stretching frequency. So let us discuss it, that is the complex. So what is the point? The metal of low oxidation state in complex favors pi back bonding. So whatever the charge on the complex is nothing but the charge on the metal atom. So whatever the charge on complex, it is the charge on metal atom. So complex and their CO stretching frequency in per centimeter. If you consider this complexes Ti CO6 2 minus, then it having a carbon stretching frequency 1748 per centimeter. Then second, that is VCO by 6, VCO by 6 minus, it having 1859, 1859. Then CrCO by 6, the next one is CrCO by 6, it having 2000, CrCO by 6, it having 2000. And two more is there, that is the next one is MnCO by 6, MnCO by 6 having plus 1, and it having 2100 carbon stretching frequency. And the next one is Fe CO by 6, in which it is in plus 2 oxidation state. It will shows 2204 per centimeter, that is Fe CO by 6 plus 2, 2204 per centimeter. So what is the point? Metal of low oxidation state in a complex favor pi back bonding. So if you consider the first complex, the charge on the complex is -2. So whatever the charge on the complex is nothing but the charge on the metal atom. So you should remember, in this case we cannot find out the oxidation state. We does not find out the oxidation state, we consider only the charge on the complexes. So we know that the carbonyl, it is your neutral ligand, and whatever the charge on this complex it is nothing but the charge on the metal atom. So this titanium, it is the titanium having -2 charge. And if you consider the other complex, the vanadium having -1 charge, the chromium complex, the chromium is neutral complex, it does not have any charge. Then Mn in +1 oxidation state, and then because Mn having +1 charge and Fe having +2 charge, so it is in +2 oxidation state. So titanium having -2, vanadium having -1, chromium 0, Mn +1, and Fe +2. So we know that, so metal of low oxidation state means the metal having negative oxidation state in complexes favors pi back bonding. As pi back bonding is increases, the metal carbon strength is increases, but the carbon oxygen strength is decreases. As in this case, there is a in this case, that is in the first example, that is TiCO6 2 minus, as there is a more back bonding, metal carbon strength is increases, but the carbon oxygen strength is decreases due to the pi back bonding. As the carbon oxygen strength is decreases, the bond order is decreases, stability decreases, force constant is decreases, and the frequency is also decreases. Therefore this complex will shows IR band or IR stretching frequency at 1748 per centimeter. And if you see these complexes from first to the last one, as we go from titanium to Fe, the charge is increases and there is a less pi back bonding. So if you consider the last example, that is FeCO by 6, it is in +2 oxidation state. So this complex having a very weak pi back bonding, and due to this, in this case the carbon oxygen strength is more due to this, because there is a less pi back bonding, because Fe, it is already present in +2 oxidation state, so it cannot donate its electron to the carbonyl ligand, and therefore there is a weak pi back bonding. And due to this, there is no effect on carbon oxygen strength, and therefore the frequency, because as the carbon oxygen strength does not change, the bond orders does not change, stability does not change, and the frequency does not change, means the frequency is more as compared to the other complex, because there is a very weak pi back bonding, and due to this complex will shows carbonyl stretching frequency at 2204 per centimeter. So this is the reason, uh, these are the factors which affects on pi back bonding. Therefore the first factor is the charge on the metal. In this case we also consider the charge, but we consider the complexes. So whatever the charge on the complex is, it is nothing but the charge on the metal atom. So as there is a more negative charge, in the first point we discussed, more negative charge on the metal atom, electron density is more, and there is a more pi back bonding. As the pi back bonding is increases, metal carbon strength is increases, but the carbon oxygen strength is decreases, and carbonyl stretching frequency is also decreases. If we see the first example, that is TiCO6 2 minus ion, in this case there is a titanium, it is in -2 oxidation state, and due to this there is a more or a large pi back bonding, a large pi donation, and due to this the MC strength is increases, but the carbon oxygen strength is decreases, and therefore carbon stretching frequency is also decreases. If you consider the second complex VCO by 6, as compared to TiCO6, there is only -1 charge on the complexes, as compared to example first, or titanium complex, with considering comparing the VCO6 minus with TiCO6, so there is a less pi back bonding, and therefore the carbon stretching frequency is much higher as compared to TiCO6 2 minus. Same is the case for VCO6 minus and the neutral complex chromium complex. So as the negative charge is decreases and the positive charge is increases, the carbon stretching frequency is also increases, because if you go from top to the bottom, the pi back bonding is decreases, the pi back bonding is decreases, and therefore and the carbonyl stretching frequency is increases. So there is a no pi back bonding, so no effect on carbon oxygen strength, and therefore the carbon oxygen stretching frequency is more. So you should remember only 2 points. That is, as the negative charge on the complex is more, there will be more pi back bonding, and due to this pi back bonding, the metal carbon strength is increases, but the carbon oxygen strength is decreases, and due to this carbon stretching frequency is decreases. As the pi back bonding is decreases the carbon oxygen strength, there is no effect on this carbon oxygen strength, and the carbon stretching frequency is more in case of positively charged complexes. So this is all about the factors affecting on pi back bonding. In the next lecture we will discuss the bridging modes of carbonyl. So up to this we know that the carbonyl, it is attached with metal atom, or it will forms the complex with metal atom by linearly, by attach, by forms a bond in linear mode, that is normal terminal ligand, it is act as a terminal ligand. But this CO, it is also act as a bridging ligands. So we will discuss the bridging mode of this carbonyl ligand, but up to this we know that this carbonyl, it is act as a terminal ligand. So what is this bridging mode, we will discuss in the next lecture. Thank you.